the problem set for last week. Okay, so this first problem is about a clothing store with many different aisles of clothing sizes, and it basically is asking us to find a specific size within all of the aisles using binary search. Like obviously you can do it without binary search, but you're supposed to use a binary search. So so what we start by doing is the problem tells us that like the first input is the number of aisles of clothing we have, and then the second input is our target value, and then we just have all the values. So we start by making a scanner. And then we get both of the first values. So the first value is just the number, so just call it n. And then the second is the target value, so just call that target. And then we need to make a for loop in order to get all of our inputs. Oh, well, first we need to make an array of all the clothing sizes. So int array, we'll just call it sizes equals new int array n, because that's how many we have. Then we just make a for loop in order to get all of the input. And then we can start writing our binary search to do this. So recall from last week, the first thing we have to do is initialize low and high. So we'll set int low equal to 0, and we'll set int high equal to the size of the array -1, because that's the last index, which is just n-1. And then we write our binary search by first starting with while low is less than high, because we'd want it to terminate when that happens. And then the first thing we do is we set like our middle value that we're going to be checking, which is just the average of low and high. And then the first condition we check is if the middle value just straight up equals the target value, in which case we've already found our answer, and all we want to do is just make sure the loop gets terminated. To make it easier, since we're just going to be printing low at the end, we're just going to set low equal to mid, and then we'll do break to break out of the while loop. And when we put like system.out.print low, when this condition is reached, like low will just get outprinted here. And then otherwise, we look at the other case. If sizes of our middle value is less than the target value, then we know that like our lowest index, like we know that the index has to be greater than mid, since it's like ordered going upwards. So we can set our lowest index to mid +1. And then the other condition is just the other condition would be if sizes mid is greater than target, in which case we know that our last index is less than middle, so then we can just set high to middle -1. And then eventually it'll find it, and as we did before, we're just going to print out low. And we don't have to worry about any other cases, since the problem specifically states that it's guaranteed an aisle will contain this and each aisle is unique. So then we just run the code. Oh. What? This is odd. Oh, oops. Wait, this is so weird. I coded this exactly the same as before. Oh, oops, this is our problem. Yeah. Okay, and then we passed our test case. And we got all of them. Okay, any questions over that problem? Okay, cool. So now we'll go to the second problem, which is square root finder. So this problem, it basically gives us an integer n, and we have to find a square root of it, and like with this accuracy specifically. And we're not supposed to use the square root method. We're supposed to use it using a binary search. So same thing, we just start by doing scanner in equals new scanner. And then what we want to do after that is we just read in the input, which is it says it will be it says it'll be a double value. So we have to do double and equals in.next double. And then we're going to do a binary search to find a value that when squared would be within 0.001 of n. So we can just set like our low value, which would also want to be a double, so the square roots like are decimals. So we just set that to 0 because like we'll never have a number that has a square root less than 0 because it's going to be positive. And then the problem says 1 is less than n is less than 10 to the 6. So then we can just set double high equal to n, because we know that like n squared will always be greater than n, but because it says it's greater than 1. But if the problem said that n was just like greater than 0, then we'd want to set high to like n plus 1, because when fractions are like the square root of fraction is greater than the fraction, so we'd have to search values greater than that also. But for the sake of this problem, we can just set it to n. And then we can also set our middle to just be equal to like anything to begin with. It doesn't really matter, but we can just set it low plus high over 2. And then so a while condition is just going to be while the difference between middle squared and n is greater than this number, because that means the loop will continually search for values until we find a middle value, which when squared is within this value. So the way we do that is we just do math.abs and then middle times middle minus n, because that'll get like the difference between our middle value squared and n. And then while that's greater than 0.00001. And then same process in this loop, we just start by making middle the average of low and high. And then we write our conditions. So if middle times middle is greater than n, then we know that like our middle value needs to be less. So our new high value can be equal to middle. And we don't do like middle minus 1, because when we do like square roots, it can be like very, very small differences. But this will eventually find the correct solution, because we have this like margin of error is 0.01. And then otherwise, we know that middle times middle will be like less than or equal to n. So then, well, it will be less than n, because otherwise the condition would have made it exit. But otherwise, then we set low to middle, because we know that middle times middle is less than n, so our lowest has to be greater than middle. And then this will just keep running, and eventually it will find a mid value that satisfies this condition, and then we just print that value. And I forgot a colon. And as you can see, it gets sufficiently close for the problem. If we made this number like larger, it would get even closer, but the problem doesn't ask us to do that, so it doesn't really matter. Okay, any questions over that one? Okay. So the next problem is just an exercise for learning how to use like the comparable class and the comparator class. You don't actually have to like solve the problem. So the problem says that you have a workshop and you want to write like different methods to sort your tools. So we have this like object called tools, and every object of tool class has a cost C and a size S. And then the natural order that you want to sort the tools is in ascending value of cost times size. And then we also want to write comparators, tool by size, which sorts by ascending value of S, and tool by cost, which sorts by ascending values of C. So all we have to do, like for this problem specifically, it just says we have to fill in these methods. So we go down here and do the method. So first, for the tools class, it tells us you can see tools implements the comparable interface. So the natural order is what the compare to method determines. So all classes that inherit from the comparable interface have to have a public compare to method, and then in there that just goes tools others, which is what we went over last week's lesson about how comparator works. And then so we wanted to sort an ascending value of C times S. So then what we can return here is just return this dot size times this dot cost minus other dot size times other dot costs, and then that will essentially make it so it's sorting in ascending order, because as we went over, if this value returns a positive, it'll put the object like it's being compared to in after, and in this case, size times cost of the initial object. If it's like greater than the one you're comparing it to, it'll put it after. So that's how that compare to method works. And then the problem also asks us to just write like two other methods, which are like in comparators, which the problem solution code will use, but we don't actually have to do that. So we just have to write the methods. So recall in classes that implement comparable, implement comparator, the method heading is public int compare tools x tools y, and then within this problem, we want it to sort by ascending order of s. So then we just we'd return x dot size minus y dot size. And then in the same way, this method is very similar. It will have the same header as well, because it's also a comparator method. And then we can just copy paste this method, but instead of sorting by size, we just sort by cost. And there's no samples, so we just have to submit and see if it worked. Yeah, and then there. Okay, any questions over that problem?
So exciting.
Okay. So then the final problem is just a sorting exercise using the comparable interface again. So it tells us that we have like a list of bears, and each bear has an attribute known as the name, the price, and the coolness rating. And then the problem asks us to return a sorted list of the bear, where we return the cheapest bear first. But if prices are the same, we return the one with the higher coolness rating. And if that is also the same, you return the bear with the earlier name first. So basically what we're going to do is we're going to create a class called bear with these three attributes, and then we can write a compare to method for it. And if we put all of that in an array list, we can just use the collections.sort method, and then we just return after what the collections.sort method has given us. So we start by we have to like create our class that would implement comparable, because it's going to be sorted. We'll just call it bear, and then so you have to write implements comparable, and then we just assign it basic attributes. We know it has a name, we know it has a cost, and we know it has a coolness. And then we make a constructor, which will take like 3 values in order to assign all these. Oh, and the problem says name is a string, cost is a double, and coolness is an integer. So then we just set name equal to n, cost equal to cost, and coolness equal to cool. So then we have all those, and then we have to write the compare to method. So same thing, we just start with the heading, public int compare to bear other. So then we go through all the different attributes. So it says first we compare by cost. So we put like an if this dot cost does not equal other dot cost, because like that's the condition we want to make sure is satisfied. Otherwise we'll compare other things, but if they're different, then we basically will just return like the difference of the two costs. So we can, since these are doubles, we can use a method called double.compare this dot cost, comma other dot cost. And that essentially is just a method which will return a comparison between these two variables and sort them in ascending order, which is what the problem asks for, since we want to buy the cheaper bears first. So we can write it like that. Now, obviously, if that condition is satisfied, then it'll return. So if that happens, like it just stops. So we don't have to put else if, we can just put another if statement. So then the second way they said to sort it by is if cost is the same. So if this like doesn't get executed, then we want to sort it by coolness rating, but we want higher coolness ratings. So we want to sort them by descending coolness ratings. So then we also have to check if this dot coolness does not equal other dot coolness. In which case we'd go to the next thing. But if they are equal to each other, if they aren't like equal to each other, then we can compare them. And since these are both integers, we can just do a simple subtraction between them. And normally we do this dot coolness minus other dot coolness, but that would sort them in ascending order, but we need it in descending order. So we flip it and do other dot coolness minus this dot coolness for this. And so that'll sort it if they have like different coolnesses, but if they have the same coolness value, then we have to default to alphabetically sorting it. So then we just return, if none of those get executed, then we return the names compared to each other. And since strings are objects, they have access to the compare to method. So we can just do this.name dot compare to other dot name. And similarly, this would just like sort them alphabetically, which is what we want. If we wanted to sort them reverse alphabetically, we do like other.name.compare to this.name. So we have like our class set up. So all we have to do is just read all the bare inputs. Then we can just call arrays.sort and then print the name. So to do that, we start by making our scanner. And then we get the first line, which is just the number of bears we have. And then we have to initialize array list. And we can initialize an array list of bears because we create like a bear object for each one. And we can just call that bears. And then we just do a simple for loop to read in all our input. And then for each input, we'll create a new bear. So bear temp equals new bear. And then we have to send the values to constructor, but since they're in order, we can just read them directly in the constructor. So we know it starts with name and the constructor asks for name first. So we can do new bear and then in.next, because that's a string. And then it goes to the coolness rating, the cost. And then we also have cost second. So then we do in.next. We have to do in.next double because the value is not an integer or a string. So we use in.next double method. And then the third one is an integer relating to coolness, which our thing also has. So in.next coolness, in.next int. And then we have to add this bear to our array list. So then we just do bears.add temp. And then after that is done, we can call the method collections.sort that we went over last week. And then that just sorts the bear array. It sorts the bear array based on this compare to method. So now we have it sorted in the order that the problem requests. And then we can just do a for loop to print out the name of each bear. So we'll use an enhanced for loop, which will pull out like the bear object at each index and known as x. Then we just do system.out println x.name. We run it, and we got it.
Okay, so we actually don't have like, okay, so like apparently Mayang, who was supposed to Mayang, who was supposed to give the lesson on trees, is not here, so we actually don't have the lesson for you. So we're gonna postpone that lesson to next week and end this meeting.
Thanks for showing up, guys.